This is a key to worksheet 4.1 part 4, and on this worksheet you are graphing exponential functions where the base is e. Now remember, e is the irrational number. Okay, now, so this is part 4, so much of our discussion will relate back to previous worksheets. Okay, so remember, in an exponential function, the domain of an exponential function is all real numbers, because I can substitute any number for x and I will get a y value back. It could be any rational number, any irrational number, does not matter. Any real number and I will get a y value back. So the domain, remember, for all exponential functions is all real numbers. That's not true for the range, though. It's only true for the domain. Now, since the domain is all real numbers, then that means that an exponential function will always have a y-intercept. It may not always have an x-intercept, but it will always have a y-intercept. So in my math lab, when they ask you to graph these using intercept, they're talking about the y-intercept in those cases. Okay, so to find the y-intercept, you're going to let x be 0 since 0 is in this domain. And so you're going to get y equals e to the 0 minus 7. Now remember, e to the 0 is 1. Any real number raised to the 0 power is 1, except 0. As long as the base is not 0, any real number raised to the 0 power is 1. So 1 minus 7 is negative 6. So I get the y-intercept of negative 6. Okay, so that means that the graph is going to cross the y-axis at negative 6. I'm going to go ahead and plot that point. Now remember, in an exponential function, it has this form, f of x equal b to the x plus c, where this constant is your horizontal asymptote. So all exponential functions have a horizontal asymptote. So in this case, and remember, it's a horizontal line. We denote it as a dotted line, but it's a horizontal line, so you have to use an equation. So you must say y equals that constant, which in this case is negative 7. So at this point, we're going to graph the horizontal asymptote. So y equals negative 7. And so I'm going to get, let's see, y equal negative 7. So let's go ahead and denote that using a dotted line. Okay, just like this. All right. Now let's talk about something else we did. Now remember, you must use 3 points. So I already have one. Okay, so you must show that point. The dot here, and then as a t-table, and then you need to plot those points. Okay. Now remember, in the previous lesson we talked about the fact that if the base is greater than 1, so since e is greater than 1, remember e is approximately equal to 2.718, then f of x is increasing, okay? Unless there's a reflection. Do you see a negative in front here? No. So there's no reflection. So that means that when I graph this, it's going to look something like this, okay? All right. Now, so I know that the tail end is going to get closer and closer and closer to this horizontal asymptote. All right, so let's plot a couple more points. So remember, you need at least 3. So you already have 1, the y-intercept, you need 2 more. So if x is, let's say, 1. All right, let's use the calculator. I'm going to get e to the first, y equals e to the first minus 7, right? All right, so use your calculator. So your exponential function is right above the ln function. You're going to use that same button. So you can press second, e, ln. All right, so the first, close the parentheses, and then subtract 7, and you get about negative 4.3. So that's about negative 4.3, right? Okay, so 1 negative 4.3 is about here, right? So you know the graph's going to increase based on the fact that this point's higher than that point. So at this point, I can just go ahead and do this now. Now remember, make sure you don't draw it to where it looks like it crosses the horizontal asymptote. Okay, even though that was not your intent, that's what it looks like. Okay, so don't do that. Just draw it far enough to where it looks like it's approaching it. Okay, and you're done with this part. Okay, now we need one more. Okay, so you see you got to show this little dot here. All right, now if x is 2, I get y equals e squared minus 7. All right, so in your calculator, you're going to say second ln, right here, second ln, and then e squared, close the parentheses, subtract 7, and that's about 0.4. So that's about 0.4. All right, so 2.4 is about here. Okay, right here. All right, so notice you get this. Okay. All right, and there you go. Okay, so that's the graph of this. Now, let's talk about the range. Now keep in mind that you didn't have to draw the graph to determine the range. Okay, it's because look, if the horizontal asymptote is y equal -7, right, and the graph is above the horizontal asymptote because there's no reflection, then that means that your range is going to be from -7 all the way to infinity. Now remember, you can't say bracket here. It must be parentheses. All right, no bracket, parentheses, because the y value is never -7. If you do a t-table, this y value will never, ever be -7. In fact, it will never be below -7. Okay? So -7 all the way to infinity. That's your range. With parentheses. No bracket on -7. All right, so that is part number 1. Now let's look at number 2. Number 2, same idea, except this time instead of x minus 7, it's x plus 2. All right, so first of all, is there a reflection? No, because there's no negative in front of that e to the x. Right away, you can tell me many things. You can tell me the horizontal asymptote. What's the horizontal asymptote? It's this constant, right? Now make sure you don't just say 2. You got to say y equal 2. Because remember, the horizontal asymptote is a horizontal line. And then we denote it. Remember, it's y equal 2, so let's go ahead and do that now. And we denote it using a dotted line. All right, so go ahead and draw it. And so I get something that looks like this. All right, and then the domain of all exponential functions is all real numbers. Since the domain's all real numbers, your graph's always going to have a y-intercept. It may not have an x-intercept. You don't know enough at this point to find the x-intercept. So notice that the graph crossed the x-axis, so it has an x-intercept, but you don't know how to find it. All right, now, so the y-intercept, you're going to let x be 0. So I get e to the 0 plus 2, right? E to the 0 is 1. 1 plus 2 is 3. So my y-intercept is 3. So the graph's going to cross the y-axis at 3. And notice that the graph is above. We knew it was above. We knew the graph's going to be above the horizontal asymptote because there's no reflection. All right, now, since I know the graph's above, I know the range right away. What's the range? Without even knowing the graph, I know the range. It's going to be from the horizontal asymptote, which is y equal 2. Will the graph ever have a y value of 2? No, it approaches 2, right? Without touching or crossing it. So we're just going to say parentheses 2 to infinity. And when we graph, you're going to see that it is 2 to infinity. Now notice that e is 2, right? I mean, e is greater than 1, correct? E is about 2.718. So since the base is greater than 1, we know that the graph's going to be increasing. So we just need 2 more points. So if x is 1, I get e to the first plus 2. E to the first plus 2. So I'm going to say second e to the first plus 2 equals about 4.7. Right? So 1, 4.7 is about here. 1, 4.7 about right here. All right, so I know the graph's increasing based on that as well. So I know that on this side it's going to do this. Okay. Again, make sure you don't go too far enough to where it looks like it crosses it. Okay. All right, and then if x is 2, I get e squared plus 2. So let's see what that is. So second ln, so I get e to the second power, close the parentheses, and then add 2. So about 9.4. 9.4. So 2, 9.4 is about here. And so you get something that looks like this. Okay? All right, so that is f of x. Okay? And notice that the range is from 2 to infinity. Okay, it gets closer and closer and closer to 2 without even touching it. So like 1.999999999 is on this graph. Okay? All right, so close to 2. Never 2, though. If you do a t-table, that y value is never going to be 2. Okay, so that is the key to worksheet 4.1, part 4.